what is your vision for this ET3? What will change?
Our vision is truly global, where a person could travel from Seoul, Korea to New York City in 2 hours and 15 minutes, and the cost would be $100 round trip.
$100
Round trip. A tenth of the cost of flying.
Amazing.
Or goods and products could be ordered a pallet at a time, minimum order, instead of a shipping container at a time, minimum order, and be delivered in 4 hours instead of 4 weeks.
How do you go about it when we start in Seoul, South Korea? How do you go through Siberia and all
there will be 2 tubes built, 1 tube for each direction on a global backbone that connects the continents together from Siberia to Alaska, across Canada to the United States.
And then from going Alaska to, how do you cross it?
And then going the other direction, it would go through India, across China, and then through India, and then to Europe.
Amazing. But from Alaska, how do you go through the ocean?
Yes, it would tunnel underground, underwater, just like the tunnel across the English Channel, except a little bit longer and less water depth, only 75 meters water depth. Shallow water across the Bering Strait.
Very interesting. So how long have you been working on this?
Well, I've probably been working on it my whole life, but I first wrote things down when I was studying mechanical engineering in the university, Walla Walla University, and I wrote ideas down in the back of my physics lab book. And those ideas I would transfer to journals, and then in the mid-90s I started getting very excited about the possibilities and started crunching some numbers. And I discovered that ET3 can be built for a tenth of the cost of high-speed rail.
Tenth of the cost, the current cost?
Yes, or ET3 can be built for a fourth of the cost of a 4-lane freeway. And the reason it can be built so cheap is because the vehicles only weigh 180 kilograms empty, but they'll haul the same 360 kilogram load as a typical car. So we only have a little over a ton of load if 2 vehicles are passing to support. Compare that to a 100-ton locomotive and the massive infrastructure that it takes to hold that up or to magnetically levitate it. And you can see very quickly why ET3 requires less than a 30th of the amount of concrete and steel to build the infrastructure.
Oh, 1/30th
yes.
of the concrete.
So we can build it for a tenth the cost and still leave plenty of profit potential for local companies to assemble it using local capacities that already exist all over the world. For instance, the ability to make pipelines. For instance, the ability to make vacuum pumps. All these capacities already exist. So ET3 is creating a new market for billions, if not trillions of dollars of existing capacities.
Oh, amazing.
ET3 could be built right along existing highways or existing railroads without disrupting the use of those assets.
Wow. Good. 두 번째 질문.
네, 자, 선생님 잠깐만요.
The first question again.
아니 앞쪽으로 쳐줘야지.
Again. And you don't stop. You go long this time. Okay, I won't ask any questions between. So you have to say that it is a travel, earth travel, space travel.
Oh, okay.
And then how it connects and all that.
하나, 둘, 셋.
Okay.
What is your vision for this ET3?
The vision for ET3 is being able to enjoy a global transportation system where a person could travel from Seoul, Korea, up across Siberia, across Alaska, across the Bering Strait, which is less than 150 kilometers of water to cross, and continuing on travel across Canada to the United States or across the United States down to South America. Going the other direction, a person could travel from Seoul, Korea, across China, across India, to Europe, and arrive in either North America or Europe in less than 2 hours. The challenge of ET3 is making people aware that there is a new mode of travel that it uses existing capacities to build it. Pipelines are being built all around the world. So ET3 can leverage those existing processes and create a new market for the production capacity that already exists. The vacuum pump making capacity already exists all over the world. The capacity to make the helical piers to put into the ground, the equipment exists. Almost any city can put those into the ground in less than 15 minutes for a 25-meter span. In another 15 minutes, the vertical support can be put in place. In another 15 minutes, the 25-meter section of double tube can be bolted into place. Every 15 minutes, another 25 meters. Compare that to the amount of earthwork that it takes to make a freeway, or the amount of work that it takes to make high-speed rail. It might take a week just to put the pilings in the ground. So ET3 can be built for a tenth of the cost of high-speed rail, or a fourth of the cost of a 4-lane freeway. And ET3, since it's automated and the vehicles can operate at very high frequencies, has 10 times the capacity. One pair of ET3 tubes that are 1.5 meters diameter each tube has the capacity of a 40-lane freeway at a design speed of 600 kilometers per hour. If you increase the speed to 6,500 kilometers per hour, each tube can carry 120 car-sized vehicles every second. So it has the capacity of a 400-lane freeway. That one pair of tubes going across the Bering Strait between Alaska and Siberia could carry all of the container ship travel between Asia and the United States that presently goes on container ships, and all the air travel, and it would still have 80% of the capacity. That would only use 20% of the capacity of that tube just for moving cargo. So ET3 can move cargo, a pallet at a time minimum shipping quantity, from any manufacturer in Korea to any Walmart store in the United States in 4 hours or less. Or apples from any grower here in the United States to Japan, where they sell for $5 a piece. So food will be much cheaper, much fresher, picked ripe instead of picked 2 weeks early. All kinds of changes are possible with ET3. Transportation is the master key to survival on Earth. If food and water can't be brought to us, or if we can't travel to get it, we perish. But with ET3, since we doubled the speed, more than double the speed of transportation, if we only double the speed, there's 4 times more opportunity in that circle of influence on a daily basis. So every time the transportation velocity increases historically, it improves the standard of living. The sailing ship in less than a generation doubled the global standard of living. And then when trains were invented, steam power, in less than 50 or 60 years, doubled the global standard of living. And then when cars and aircrafts were invented, again, it doubled the global standard of living. ET3 has the potential to, again, double the standard of living, displacing cars and aircraft, just like cars and aircraft displaced trains, and just like trains displaced muscle power. So we can have a new paradigm shift in transportation that allows people to live much easier. What this will enable is if every country in the world develops this to the same standard, building it to the same diameter tubes, so it can be networked together eventually, like the internet is networked together, we can have travel between any cities in the United States in 4 hours or less. All it takes is the will to do it, and the knowledge. The knowledge is already there, the capacity is already there, The political will is a challenge. All countries will need to cooperate to build it to the same standard and to figure out where the best routes are to cross borders. Those are the challenges that we face.
Okay.